Section 4.3, matrix multiplication. Scalar multiplication multiplies a matrix A by a scalar C, where C would be just a real number. To find the resulting matrix C times A, C being the scalar, which is a real number, and A being the matrix, we just multiply each element of the matrix A by that scalar real number, C. When we do that, the properties of equality hold. Closure, associative property of addition, distributive property, multiplicative identity property, multiplicative property of zero. Let's take a look at an example. Use the matrices A, B, C, and D to find each product, sum, or difference. On number 1, they want me to find a negative 3B. This is a negative 3, my scalar, times matrix B. And here is matrix B. This is a 2 by 3. So what we want to do is to rewrite my matrix with my scalar out front, which is a negative 3. Now, all I have to do is multiply the negative 3 times each element of the matrix. Negative 3 times 4 is a negative 12. Negative 3 times a negative 1 is 3. Negative 3 times 1 is a negative 3. Negative 3 times 0 is 0. Negative 3 times 2 is a negative 6. Negative 3 times 3 is a negative 9. Our next example, I have a negative 1 times C. That's a negative 1, which is our scalar, times matrix C. Now, all I need to do is to take a negative 1, doesn't have to be shown, and multiply that by each element in the matrix. Negative 1 times 2 is a negative 2. Negative 1 times a negative 3 is 3. Negative 1 times 1 is a negative 1. And negative 1 times a negative 2 is 2. Our next example, 2C, which is my scalar 2 times my matrix C, minus 3 times my matrix A. When I have this set up, I have my scalar times matrix C and 3 times my matrix A. Now there's two ways that we can actually solve this problem. We can take 2 times each element here, and then also we can take just 3 times each element here, and that would result in still having a minus sign. I didn't take the negative 3 into each element. All I did is take the 3, leaving my minus sign here. I could have done it the other way, and of course multiplied each element by 2, and notice in both I would have 4, negative 6, 2, negative 4, 4, negative 6, 2, negative 4. But in this case, I took a negative 3 times each element. Negative 3 times 3 is a negative 9, negative 6, negative 3, and negative 12, but that would change to a plus sign. In both instances, I would have the resulting matrix be the same. 4 minus 9 is a negative 5. Negative 6 minus 6 is a negative 12. 2 minus 3 is a negative 1. And negative 4 minus 12 is a negative 16. And we can verify both processes by doing the same. 4 plus a negative 9 is a negative 5. Negative 6 plus a negative 6 is a negative 12. 2 plus a negative 3 is a negative 1. And negative 4 plus a negative 12 is a negative 16. So either process, you can have a resultant that is the same. On my next example, they want me to solve each matrix equation. In this situation, I have 4x minus 2, the scalar, multiplying this matrix equals this matrix. I need to simplify first by multiplying this scalar times my matrix. In this situation, what I decided to do was to multiply by a negative 2. When I do that, I bring down my 4x. Negative 2 times each element gives me a 2, a negative 6, 10, and 0. But since I used the negative in my multiplication, this will change to a plus sign. You could have just brought the minus sign down and then just multiplied by 2. Our next procedure is to eliminate this matrix. So that means, since this is added to my variable term, I need to subtract this on both sides. And when I do, it looks like this. Over here, these two matrices will cancel each other out into a 0, and that will just leave me with a 4x. Then I will have a resulting matrix by subtracting each element of the two matrices. That's going to give me 4 minus 2 is 2, negative 2 minus a negative 6, which is a negative 2 plus 6, which is 4, 5 minus 10, which is a negative 5, and 6 minus 0, which is 6. Now, I need to simplify this by multiplying both sides by 1/4. And the 4's will cancel, and that gives me x, which is what I'm trying to solve for. Now, what I have is scalar multiplication on the right side. My scalar is 1/4, and I take that times each element on the interior. 1/4 times 2 is 2/4, which is 1/2. 1/4 times 4 is 4/4, which is 1. 1/4 times a negative 5 is a negative 5/4. And 1/4 times 6 is 6/4, but 2 divides into both, which will give me 3/2. And this is the solution for x. On this example, I want to solve each matrix equation. I want to solve for my x. I notice that I have a negative matrix that is being added to it. Therefore, all I need to do is to add that matrix to both sides. So when I add 4, negative 2, 5, 1 matrix to this side, that eliminates this matrix. And now I just needed to add it to this side. So what I'm left with on the left is a negative 2x, which equals, and all I have to do is perform the addition of corresponding elements in these matrices. 3 plus 4 is 7. Negative 3 plus a negative 2 is a negative 5. 0 plus 5 is 5. And 4 plus 1 is 5. Now we have a negative 2 multiplying my variable. So I need to perform the inverse operation, which is to multiply by a negative 1/2 on both sides. And that leaves me x on the left. And then scalar multiplication with the matrix. Negative 1/2 times 7 is a negative 7/2. Negative 1/2 times a negative 5 is a positive 5/2. Negative 1/2 times a positive 5 is a negative 5/2. And a negative 1/2 times a positive 5 is a negative 5/2.